The Vilas Sarkar. The next problem of our discussion, the numeric problem on fluid statistics with the problem number 22. And problem number 22 it says the problem number 22 is saying that a stone of relative density, a stone of relative density K is released K from rest on the surface of a lake on the surface of a lake. It if viscous effect are ignored, effects are ignored, the stone sinks in the water with an acceleration of the stone sinks into the water with an acceleration of how much? Means you have to find the acceleration of the stone while it is sinking down. So that means if I assume a lake and a ball is being dropped from air, it is dropping with an acceleration, and after some time it will be somewhere there hitting the surface of the lake. So you have to find the acceleration. Now one thing is there if the viscous effect are ignored, what does the viscous effect will do? The viscous effect, that means while it is passing through the water of the lake, it doesn't being resisted by the friction. Additionally, the friction that will come for two media being contacted, means solid and the liquid medium being contacted each other, there will be always a frictional loss due to their contact while they are moving into the media. So that means that friction is absent here, it is non-viscous. Okay, this is one thing. So we will not consider any loss due to the friction. So only that force can be eliminated. Now we can understand why it is submerged. What are the forces it is being influenced upon? The weight of the solid, the buoyancy, the upthrust. Okay, so now this, apart from this, no other force is acting on this stone. So as it is going down with an acceleration, that means weight of the solid is overcoming the upthrust. That means the overcoming force, we can say the overcoming force FO is being created due to the difference between these forces, the weight, the force acting on the stone downward, and upthrust which is acting upward. So there is a balance, and this is the equation. Now what is here this force, any force acting on this on the stone, and let's say this is creating creating an acceleration A. So that means mass into acceleration. it is the force because force is nothing but mass into acceleration, and here this is mass into the gravitational force, and after this your mass of fluid dispersed into the gravitational force. These are the three things, because upthrust is what? Volume of the fluid dispersed, density of the fluid dispersed into G. Now, as this is equal to the volume of the solid here, so that means the mass here will be the fluid of equal volume of the stone being dispersed, and with the density it will give you the mass of the fluid. Here mass is the mass of the solid, and this is mass of the solid. Okay. Now let me write what is the mass of the solid. Mass, volume of the solid, rho of solid into acceleration, mass of solid, rho of solid into G minus mass of the fluid and rho of the fluid into G. Okay. Now further sorry. The volume of the solid, rho of the solid, and this is the volume of the fluid, density of the fluid, and this. Now that volume of the solid equal to volume of the fluid, as it is completely submerged and going down. So this effect of this can be eliminated. So what will remain? The density of the solid into A, density of the solid here also into G minus density of the fluid into G. This will remain. The stone is relative density is. Now what is fluid here? Rho of fluid means rho of water, because the lake is of water. There should not be any other natural lake where apart from water is existing, so I can take this as water. Okay, so my equation will turn into density of solid into acceleration is density of solid into G, and this is density of water into G. Let me divide all this by density of water into G. With this I am dividing. So what I will get? Density of solid by density of water, A by G, is equal to, this is density of solid by density of water, G will be cancelled, and this will be 1. I am dividing it with this. Okay. So now what you have to find? You have to find the acceleration with an acceleration of how much. So you have to find the acceleration. Now can you say what is this density of solid by density of water? This is relative density of the solid, and which is said to be how much? K. This is the relative density of the solid. So this part you can say is K into A by G is equal to K here also minus 1. So now this will be how much? K into okay, so A by G, I can write K minus 1 by K. K will be divided there. Now I have to find the acceleration. So acceleration is equal to G into 1 by K. So this is your answer. So acceleration in terms of gravitational force and the known relative density is this one. Understood? Okay. We'll move on to the next problem, that is 23. 23. A stone of density a stone of density 3000 kg per meter cube is lying submerged in water in water of density 1000 kg per meter cube. if the mass of the stone in air is 150 kg, calculate the force required to lift the stone. So, submerged. Let's say this is the container. Okay, the stone is submerged. Okay, so and the mass in air, it is this much kg is given, density is given, density of the fluid is given. So we have to lift it up. So if it is in case what are the force that is acting? This is weight of the solid and the buoyancy or upthrust. These are the force when the something is dipped in a fluid, that is automatically will come. Now question is that calculate the force required to lift the stone. So that means if the stone is tied with some with some string, so some force is needed to overcome the force or to balance, at least to balance, to lift it up. How come? So if the force is F and the force that is resultant of the two forces Ws minus upthrust, we assume that if it is needed to lift up by any force, additional force, so that means this is positive. So that means the weight of the stone is higher than the upthrust. Then only it needs to be lift up with an additional force. Otherwise, if upthrust is more, it is automatically lifted. There is no force it is needed. So when this at least is balanced, means these are equal, then it may go up. Okay, without any acceleration, with a constant velocity. Okay, this could happen. So this is the least force that will equalize this to lift it up. Any other force more, it will give an acceleration. That you understand, any residue force up there, that will cause an acceleration. So unless there is an acceleration, so if it is equal, so it will lift with a constant velocity, that we can say. So now, fine. So there we have some empirical formula also. What is that? The formula, if you remember, apparent is air into 1 minus rho F by rho S. This was the formula? Yes. So this is apparent weight, or from the initial formula, if I go with that, this is the what you can say, the formula that will consider to find the apparent weight. What is the apparent weight? The weight on when a body is submerged, it will feel by the body, or actually that can be detected. Why this apparent weight will come? Apparent weight is the weight that is reduced by the upthrust. The actual weight reduced by the upthrust. That is the apparent weight. So this concept will use to find the force. So why that? So whatever the apparent weight, that means that weight will act downward, will be balanced by that. So the apparent weight is nothing but this one. If I can remember, when I was discussing the theory, this concept is used. Apparent weight is nothing but the weight, the force, that is residue force, actually working down, and that is the actual weight of the solid minus the upthrust, that is reducing the weight. So that is the apparent weight. Now I am using the same thing. What is that? If I say that apparent weight is the weight of the solid minus upthrust, and this is nothing but this formula. How that is can? Weight of the solid, where we are measuring this weight of the solid? In air. So this is straightforward, the W air minus this is upthrust. So upthrust, how come this part? Because if I break it, rho F rho S into W air, how come this part is equal to upthrust? Let's see. So WF, rho of F fluid on which it is dipped, a solid, into what is W air? W air is the volume of the solid, rho of the solid into G. Now see what is we are getting, the volume of the solid, rho of the fluid into G. Now how come this is coming in picture? Because when the body is submerged in the liquid, this Vs is equal to Vf. So from there we can write this is nothing but the Vf rho F into G, upthrust. So this is the value of the upthrust. So you can correlate this both equation. So basically what we are equalizing, the weight reduced due to the upthrust. This is being transferred here. So either you can straightway use this formula for your time saving purpose, or if you know the concept, you can go with this formula. So let me use this formula first. So this is here, it is the force needed. This is equivalent to the force needed to lift up. As I said, if it is even equalizing the force downward with this will be the force needed. So apparent weight, equivalent weight, force is needed to lift it. This is working down and the force is acting up, but numerically the force needed will be equal to the apparent weight. Now I am putting this value. W air is nothing but the M air into G, 1 minus rho F means rho of the stone, rho of the liquid is water, by the rho of the solid means the stone. Now do you know all this parameter? Yes, we know. The mass of in air, it is 150. G we can take 10. It is in kg, so meter per second. What about the other one? These all are in SI unit. This is 1000. So 1000 divided by 3000. Okay. So this is nothing but 150 into 10 into 2/3. So 350. So that means 50 into 200 into 10. So that means 1000. So what we are expecting, that is W apparent, that is equivalent to the force needed. So force is here, it will be Newton, because the force unit in SN is Newton. So this much. So from using direct formula, I am getting Newton. So let me try the conceptual way. Instead of using the direct formula, if I go with the conceptual way, so the force needed, directly I can say the residue force downward, equivalent force will go up. what is your weight here? Weight of the solid, the mass of the solid into the rho of the solid. Rho of the solid is 3000 minus upthrust is volume of the solid. Volume of the solid is equivalent to the volume of the liquid. So Vf will come. Vf, how will it come? Mass of the solid divided by the density of the solid, then the volume will come. So mass of the solid is 150 here, by the density it will give the mass of the solid, that is equivalent to mass of the liquid. What I am saying, this is mass of the solid into the rho of the solid, that will be the weight of this, into g. Sorry, g has to be there, so I have to multiply it with 10 further, so into g, and upthrust is equal to the volume of the fluid, rho of the fluid into g. What is this? This is volume of the solid. This is nothing but the mass of the solid by the density of the solid. So mass of the solid, density of the solid into the, what will come? Density of the fluid into g. So this all. Now what is this? How will I reduce this? This is 353 into 50, that is equal to 500, and into 5, this is 500. Volume of the solid, mass of the solid by the density into this is volume into density into rho. So this is fine. So this is mass of the solid, this is density, mass of the solid is there. Sorry, why should I multiply with this one? Sorry, I made a mistake. This will be the mass of the solid into only the g, weight of the, this is will be this one. Sorry, I made a mistake. So weight of the solid is equal to mass of the solid into g, and whereas upthrust is equal to volume of the fluid, rho of the fluid, and g. Volume of the fluid is equal to the volume of the solid. This is mass of the solid by rho of the solid. So volume into the rho of the density of the fluid into g. Okay, fine. So this is 1500 minus this 50 into 10. This is equal to 500. So all total this is 1000 Newton. So with both the process we can approach, if you remember the formula well. Otherwise, if you go with the conceptual way also, you will get the result. Okay. So we will move on to the problem number 24 now. So the next problem is number 24. Number 24 says a piece of steel has weight W in air, W1 when completely immersed in water, and W2 when completely immersed in an unknown liquid. The relative density or bracket specific gravity of liquid is how much? Okay. So now, what are the thing is given? It is piece of steel has the weight of W in air. That means if I assume the solid having weight, solid or the steel weighing W, that means in air, that means W air you can say, and W1 the apparent weight in water, because it is weighing W1 when completely immersed in water, that is the apparent weight in water is W1, apparent weight in unknown liquid WL is W2. So when in water, so in that case what would be the equation will stand? Apparent weight W1 will be equal to the actual weight in air minus upthrust in water. So upthrust in water is how much? So this, instead of W air I will write W as it is given in the question. This is equal to the volume of the solid, because this is nothing but volume of the fluid, rho of fluid into G. So that volume of the fluid, rho of the fluid into G, if I take, it is equal to W minus W1. Volume of the fluid is nothing but volume of the solid. You can put anything, rho of the fluid. The rho of the fluid is rho of water into G, that is equal to W minus W1. So this is my first equation. When in unknown liquid, so my equation will be W2 is equal to W, that means W air, I will write the first one, minus upthrust in unknown liquid. So W is equal to, W air is equal to W, okay, minus upthrust is equal to same, V of volume of fluid, unknown liquid into rho of unknown liquid into G. So V of unknown liquid, because it is completely immersed, so equivalent to V of solid, rho of unknown liquid into G, that is equal to W minus W2. This is my second equation. Now I divide. Now what I have to the relative density of liquid. Okay, so I will divide 2 by 1. Dividing 2 by 1. So what this divide by this, volume of solid will cancel, Gg will cancel, remaining is rho of unknown liquid by rho of water is equal to W, this will come on numerator, W2 by W minus W1. Okay, no other things will remain, so I will rub it out, so no need of further this portion. So what is this? Rho of unknown liquid against rho of W, this will give the relative density of the liquid, okay, at that parameter, that temperature. If it is has to be the standard one, then we have to bring this water in 4 degree, but otherwise this will the relative density of that liquid with that water at that point of time, that temperature and whatever it is maintained. So this is the relative density, because that they don't need the relative density of the liquid at a particular temperature. Okay, if that has to be standard, then I will to bring that water at 4 degree. Otherwise, relative density at any time is the ratio of the density of the object or the item against water. This is relative density, and this is equal to this, or this is your answer. This will be your answer. W minus W2 by W minus W1 will be the relative density or the specific gravity of the liquid. Okay. So So I will end up here, and the next video I will start from number 25. So thank you for now.